Hi. Okay, find the differential equation. Find the find the particular solution to the differential equation y prime prime plus 4y equals 3 sine 2x. So in this case, we want only the particular solution. Okay, so what we are about to do is that we write this y prime prime plus 4y in terms of d or a derivative. You see, this is a second derivative, but we can also donate this as you can also donate this one as d squared. So we are getting d squared plus 4. So f of d will give us d squared plus 4. Then we make this substitution. We let d squared should be equal to minus b exponent 2. So this is my b, because you know that the f of x, this function, is in the form a sine bx. So upon comparing this to this form, that my constant, which is the a, is 3, and this is the sine 2x. So sine bx, it means my b is 2. So that's why I wrote b to be equal to 2 here. And remember, this is a case 2, because we've already, from our previous lessons, we already solved the case 1, where the f of x is in the form is where f of x is in the form e exponent something, let's say 2x, e exponent 3x, or exponential functions. But here, when the f of x, this part is termed as the f of x, is equal to a sine function, this is the shortcut I am teaching you, that without going through all the procedures after you finding your trivial solution and differentiating it. No. To save time, imagine this one comes in session A or OBJ, straightforward. We find the inverse of the f of d. So we are going to get 1 over f of d multiplying f of x. So remember, my f of x is my 3 sine 2x, whilst my f of d is the d squared plus 4. So I'm getting 1 over d squared plus 4 multiplying 3 sine 2x. So you know that you see my d squared is equal to minus 2 squared. So it means my d squared here is minus 4. So minus 4 plus 4. It means you are getting 0. So 1 over 0. When you get the denominator, upon substituting this, and let's say the denominator yields 0, it means that we have to introduce a certain constant, x. So since the denominator is 0, we make the function unique by introducing x and differentiating f of x. So anytime you have such question and you try to substitute your value inside your d squared plus 4 and you get the denominator to be 0, you make, or you introduce a constant, say x, on the numerator. So where it was 1 over d squared plus 4, now our 1 will change to x. We are doing that because we want it to be unique. You get it? We want it to be unique. So we are getting x over my f prime. So here, upon writing the constant as the numerator x, then you divide by the derivative of your f of d, this one, the derivative of this. So when you differentiate d squared plus 4, you are getting 2d. So my derivative of f of d, so we are getting x over d squared plus 4 multiplying 3 sine 2x. So I find my derivative of this, you are getting 2d. Remember, x is a constant. We brought the just to make our function unique. Okay, so we are getting, then after that we integrate the x over your 2d. But remember, because s is a constant, we are only concerned about the 2d. You know that 2 is a constant and d is a derivative. So anytime we integrate a derivative, the derivative is going to cancel the integral. So when we integrate x over 2d, remember the x is constant, 2 is constant, but because we are integrating a differential, the differential will take away the integral, so you are going to get x over 2. Then the integration will affect this. So when we integrate 3 sine 2x, we all know how to integrate sine. Okay, so you integrate or you differentiate the one inside the sign. So the function inside is 2x. So when you differentiate 2x, you are going to get 2. Then you differentiate the whole of sine 2x. So when you differentiate sine 2x, you are going to get minus cos 2x. Then when you differentiate the one inside the sign, which is the 2x, you are going to get 2. Then you divide the whole equation by 2. That's how we had x over 2 times minus 3 cos 2x all over 2. Then after that, we further simplify it. You are going to get minus 3 over 4x cos 2x. Thank you.